Welcome everybody, this is Audrey Castonia going through a little bit on a Module 4 to help us out with our linear graphs and our linear equations. The topics that will be covered here, we're going to talk about the slope formula, introduce that slope-intercept form, the difference between that and the point slope form, talk about the standard form, sometimes called the general form, and then discuss parallel and perpendicular lines. The formula for the slope is that m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now the reason for the little sub numbers are simply because all of our points are x's and y's, and we have to decide which ones are we putting in which order in this equation. The formula decides that you need to have the pairs here 2, 2, okay, so x sub 2 and y sub 2 would be 1 point, and x sub 1 and y sub 1 would be another point. So your points are always in that form of, oh, if it's an x with a sub 1, the y with the sub 1 matches up with it. And then the same thing, x sub 2 goes with y sub 2. So the little sub things are simply because all of our points are x's and y's, and we need to tell the difference between them. It does not matter which point you call x sub 1, y sub 1, and which point you call x sub 2, y sub 2. What matters is that the 1's go together and the 2's go together. So here if it says find the slope between the 2 points, we also have to be very careful about the fact that a subtraction in our formula is not the same thing as a negative number. So we have to keep that in mind. So in this equation, or with this problem, we have m is equal to, and if we want to start here, notice this is one of the few times in math land that we are not alphabetical. Y's are first, then x's. So make sure that you're very careful that it's, here's a y value, here's a y value. So it's -3, and I'm subtracting the 7. Now here's the key. Because I started with the -3 on top, I must start with its partner, the 15 on the bottom. 15 minus, and what am I subtracting? I'm subtracting a -11. I need to put that negative in there separate from the subtraction sign. And now we simplify. If I have -$3 and I'm taking away $7, I'm more in the hole. I'm now $10 in the hole. 15, take away a negative, which is what I like to call a change. What I mean by change is I change the subtraction to addition, and I change the sign right after it from a negative to a positive. So this is the same thing as 15 plus 11, which is going to give us 26. Now fractions are fantastic for slopes because a slope is a rise over a run. The top number is how far you move vertically from one point to another, and the bottom number is how far you move horizontally from one point to another point on your line or in the equation. So we like fractions because then we can clearly see that. However, we always want to reduce our fractions. Both of these are even numbers, so I know 2 goes into both of them. Or to get us more prepared for future algebraic concepts, we could rewrite the -10 as 2 times a -5, and 26 is 2 times 13. They both share a factor of 2. That's what gets canceled. Anything on top that matches with anything on the bottom, is 1. 2 divided by 2 is 1. 1 times anything just gives me my anything back. So my slope is -5/13. Do not convert this to a decimal because the decimal would be a never-ending decimal, or it's a repeating decimal, and we don't want that. We want the exact answer. It's written most compactly as -5/13. Now, does it matter that I used 15 -3 as my x sub 2, y sub 2? What if I had done it the other way? Would I get the same answer? Well, let's check it out. So on top, instead of starting with the -3, let's start with 7. So it's 7 minus, now once again, the 3 is negative. That's different from this subtraction sign. So I need to put that in parentheses. I'm subtracting a negative 3. Now, because I started with the 7 on the top, I have to start with its partner, which is the negative 11 on the bottom, minus 15. 7 minus a negative 3, remember that's that change. It's 2 changes or none. So that's 7 plus 3, which is 10. And on the bottom, I'm negative 11, and I'm taking away more, which means I'm going to be more in the hole. So we add the numbers and keep the negative. Notice it's the same as what we had up here, but the negative, instead of being on the top, is now on the bottom. That's okay. Negative fractions can be written in 3 different fashions. You could have a negative 1 over a positive 2. You could have a positive 1 over a negative 2. Or you could just put the negative out in front. Textbooks like to stick it out in front. I like to stick it on top because then I see it. I don't like to use it a whole lot on the bottom because we have the tendency to lose it then. But this is the same thing, so I can move that to the top. Why? Because remember, fraction is a division problem. A positive divided by a negative. Oh, whoa. Let's try that again. A positive divided by a negative is a negative. And a negative divided by, oops. First time with this new program, please. And a negative divided by a positive is also a negative. Okay, that's why it does not matter whether the negative's on top or bottom. But what we do need to remember is that a negative divided by a negative, 2 negatives, is a positive. Okay? So the negative's either on top or on the bottom. If there's 2 of them, you have to simplify it to a positive. If it's only one spot, you keep it in just that one spot. So a standard equation, or a usual equation, or most common equation that we have the tendency to see is one that's in the slope-intercept form. That's good old y equals mx plus b, where m is the slope, which is your rate of change or your rise over your run. And b is the y-intercept. Looks like I can't spell. The y-intercept is where the line crosses the y-axis. So if we're given an equation like y equals negative 1/5 x plus 3, it's pretty easy to graph something like this, identifying the different parts in your equation because we are in this slope-intercept form, which has y all by itself. The slope in this is negative 1/5, and our y-intercept is 3. So if I draw a nice little straight, sort of straight lines, and we graph this nicely out, because we've identified what a y-intercept is, it's where the graph crosses your y-axis. Remember, the horizontal is your x, the vertical is your y. Understanding these different pieces allows us to graph easily. So the first thing we do is we plot the y-intercept. The y-intercept is the number that's over here by itself. In this case, it's a positive 3 because we are adding, so that's where we're going to cross the y-axis. Why is that? Well, to be a point on the y-axis, the x-coordinate would have to be 0. In y equals negative 1/5 x plus 3, if I replace x with 0, this term goes away and I'm just left with y equals 3. That's why the number at the end is your y-intercept. So right here, that's the point 0, 3. That's the point where the graph crosses the y-axis. The slope tells us how we travel from one point to another point. Slope tells us how we travel vertically, then horizontally from one point to another point. So in this case, our slope is negative 1/5. So I rise a negative 1, and to rise a negative 1 means that we're going down, and then we run 5. So from this point, because it's how I go from one point to another point, so from this point, I go down 1, and then over 1, 2, 3, 4, 5. Where I end, that's another point on my graph. I can do that again, go down 1 and over 1, 2, 3, 4, 5. Now I kind of run out of space there, but if I wanted another point, instead of going down 1 and to the right 5, as I just discussed in the last slide, I could look at that fraction as 1 over a negative 5. So I could rise 1 and go back 1, 2, 3, 4, 5. Up 1 and back 5. After you've made a couple of points by traveling by your rise and run of the slope, we connect the dots. Whee! Ooh, I really should find a line drawer for me. And sometimes you make your line a little thick so that it goes through all those points. Okay, boop. So when the equation is in slope-intercept form, it's really easy to identify what's the slope and what's the y-intercept. The slope is the number in front of x, and the y-intercept is the number by itself, when y is all by itself. Sometimes they give us a point and a slope, and they say, hey, write the equation, and they don't want it in y equals mx plus b. You look at your multiple choices and you're like, that doesn't seem simplified. Exactly, because another nice equation is called the point-slope form. It's called the point-slope form because you use it when you're given a point and the slope. Okay. This looks a little bit scary, but it's actually not a new equation for us. What? No, this is the same as our slope formula. It's just solved so that you don't have the ugly fraction, which we're very thankful for since we don't like fractions. And they get rid of the 2's because the equational line needs to have an x and a y. The x and the y are your variables which represent all of your points, which are solutions. And those points are what forms your line. So we need to have an x and a y to have a line with a slant to it. And that's why we lose the little sub 2's here, and you just have the x and the y. So in this example, it says write the equation of a line with a slope of -4 and goes through this point -2, -3. Since they give us a point and a slope, we use the point-slope form. We're going to have y minus my y value. Once again, be very careful here. The y is the second value, and the formula says to subtract That's not the same as this negative. So it's y minus a negative 3. That's equal to my m, which is slope, so it's negative 4, times the quantity of x stays x minus my x value, which once again is a negative, so I need to put parentheses in there. Now, this isn't going to be one of your choices because it's not simplified. We don't write things with subtracting a negative. We clean that stuff up. So subtracting a negative would be the same thing as writing it as y So we have our y plus 3 equals negative 4 times x plus 2. And this would be your equation in point slope form. Perfectly legitimate to have this as your equation. Now, I don't like them like this. I like to have them cleaned up, but your problem, you have to look at what your multiple choice answers give you. And you're going to have problems which there's your answer. That's all you have to do to it. And maybe you have to experiment with x's and y's. Remember, any x and y pair that makes the left side equal the right side is a true statement and is a point on this line. Now, one of the things that I would do in this problem is clean it up, because maybe my answers don't look like this. Maybe my answers are in slope-intercept form. Then what? Well, then I clean it up by getting rid of my parentheses using your distributive property. So I'd have y plus 3 equals negative 4x minus 8. And then get y by itself by subtracting the 3. To get a final equation of y equals negative 4x minus 11. Both of those equations are true and are correct. Another form of a linear equation is called the standard form. This is when your variables are on the same side. It's ax plus by is equal to c. Now, when I'm teaching a residential class, I always tell students that this is the Audra form, or my form, mainly because my initials are indeed A, B, C, and it's all about me. But that's just because I'm the youngest of the family. I digress. So when you have ax plus by is equal to c, it's really great to have it in this form if you want to find both intercepts. This program's not going to work. It's really convenient to find your to find both of your intercepts. The x-intercept is when the y-coordinate is 0 and you find a number for x. The y-intercept, as we talked before, was when your x value is 0 and you solve and you find a value for y. Just having those 2 points, you can plot those 2 points to graph your line if need be. So that's why it's really convenient to have your equation in standard form with the x's and y's on the same side. However, we do a whole lot more with finding slopes and needing to know that constant rate of change between 2 points. So oftentimes they'll give you a problem like 5x plus 4y is equal to 12, but they're going to ask you for the slope and the y-intercept. Now that's going to include rearranging the equation. This is the types of steps that we did in 2 weeks ago's equations. Rearrange equations. Why would I need to do that? Well, here's a prime example. So remember, to put it so that we can find the slope and the y-intercept means we want the equation solved for y. That's that y equals mx plus b form. So in this equation, in order to do that, we need to move the term that doesn't have the y in it, which is the 5x. To move terms, we always add or subtract. Because it's a positive 5x, we subtract 5x. That leaves me with the 4y. Now on the right side, 5x is not the same as a 12. Those are not like terms because the 5x has an x and the 12 does not. You can only add or subtract like things in Mathland. Those are not like things, so we can't add them. What I am going to do though is I'm going to make sure that I put my variable term, the term that has the variable in it, first. So I'm going to write it as negative 5x plus 12. Now, adding and subtracting, we can only add and subtract like terms. But when we're multiplying and dividing, anything goes. So my next step is to get the y separated from the 4. The 4 next to the y is multiplication, so I have to divide to cancel that out. As I just stated, when dividing though, I have to divide every term. The 5 and the x make one term. I just divide it once. And the 12 is by a different term because terms are separated by plus or minus signs. So here the 4's cancel out to a 1, and 1 times anything is anything, and that's how I get my y by itself. Now the negative 5 cannot be divided by 4 nicely, so we just write it as that fraction, negative 5/4. With the x in the middle, don't put it down by the 4 because that's a different notation, in the middle or on top after it. Plus, and 12 divided by 4 is 3. So now that we're in this form, we can identify what's the slope and what's the y-intercept. The slope, of course, we recall, is always the number in front of x when y is by itself. So the slope is negative 5/4. The y-intercept is the constant at the end. So the y-intercept is at 3. Now you probably want to write that as a nice little point. Y-intercept is always when x is 0, my y value is, in this case, the 3. Now, wouldn't it be great if there was a faster way to do that? Let's go back to what I stated earlier about rearranging equations. In this case, we have ax plus by is equal to c. Oy. What if we solve this equation for y, keeping the a and the b and the c as letters. Let's do the same steps as what we did over here. First, we subtracted the term with the x. So the same thing here, to get by by itself, I need to subtract ax. So now I have by, and I still can't combine the c and that ax because they're not the same, equals negative ax plus c. And just like we did before, now let's divide. And when you divide, you have to divide every term. This ends up giving us y is equal to negative a over b with your x, and at the end we have c over b. So let's draw a conclusion from this. Our m value, the slope, is the opposite of your a value over b. Opposite of the a value So your m is equal to the opposite of a over b, and the b, or your y-intercept, is equal to the c over b. So when you're given an equation that's in this standard form of ax plus by is equal to c, you don't have to do all this math if you can remember, or have written down next to you, that the slope, when you're in this form, is the opposite of this a value. So if it's positive, it goes negative. If it's negative, it goes positive, divided by this b value. And the y-intercept is taking the c value and dividing it by b. It's a little bit easier then for this equation that we have. Right here, if we look at the 5x plus 4y is equal to 12, m is equal to the opposite of my a value, so that's the opposite of 5, all over my b value, which is a positive 4 because there's a plus sign in front of there. The y-intercept is the c value, which is 12. Divide that by your b value, which is 4, and then simplify. And without doing as much mathematics or as much thinking, we found our answers for the y-intercept and the slope when the equation is in standard form. Finally, we have parallel and perpendicular lines. Parallel lines are lines that never intersect. That means that they have to rise and run the same rate. They go up and over, up and over, up and over, and it has to be the same amount up and the same amount over to not touch each other. In other words, they have to have the same slope. So the slope of one line, the first line, is equal to the slope of the other line. Come on. Come on. Well, now I'll catch it. Wolfer. Okay. So if you're given an equation of a line, you need to find the slope of that one, and then use that same slope with what other information they give you to find your other line or whatever information they're giving you. Now, if they're asking for perpendicular lines, those are special lines. They intersect, but they intersect at a 90-degree angle. That means that one slope has to be positive and one slope has to be negative. But they can't be exactly the same. They end up being reverses or inverses of each other, which we call reciprocals. So if the slope of one of our lines was 2/3, then the slope of the perpendicular line would be flipped over, so the flip of 2/3 is 3/2. And because 2/3 is positive, this one would have to then be negative. You can tell that two slopes are slopes of perpendicular lines because if you multiply them, you will get -1. But with all that said and done, let's go through and do an example here. Write an equation of a line that contains the point -2, 4 and is parallel to y equals 2x minus 3. So the first thing we need to do is find the slope. Of the parallel line. Okay? And the slope of this line is right here at 2. So we know that the slope that we will be using, because they're parallel, has to be the same slope. So I'm using m is equal to 2 for my line. Really? So now I have m is equal to 2, and I have this point, -2, 4. Well, if I have a point and a slope, I should probably use the point-slope form. Well, I'm not using this program again for my next video. Remember, that was the equation of the slope formula, just resolved. And then I'll just magically fill those in, remembering once again that the subtraction is not the same as your negative when you substitute that in. So you don't have to wait for my time. I'll pause this and put it in. So I substituted in the 4 for my y value, the 2 from my slope because they share the same slope, and the -2 for my x value. Subtracting a negative, boom, boom, once again is adding a positive. Then I distributed through the 2, and added 4 to get y by itself. So this is equivalent to y equals 2x plus 8 if they asked for the equation in the slope-intercept form. We're going to do a very similar thing for this second part, which says, hey, now do the same problem. It goes through the point -2, 4, but instead of it being parallel, make it perpendicular to this line. So that's going to just change one little thing here. We know that the slope of this line is 2. So all we now need to do is say, well, what's the slope of the perpendicular line? Now remember, we need negative reciprocals. So 2 can be written as a fraction as 2 over 1. So to flip that over, we'd have 1/2, and then we need the opposite sign. This one was positive, so my slope is now going to be a negative 1/2. So instead of this 2 in here, I'm going to have a negative 1/2. Now I'll show what that looks like. So once again, it's that same form. Here's my 4, but now my slope is a negative 1/2 because that's the slope of the perpendicular line. I cleaned up my subtracting a negative into adding a positive 2 here. Distributed through the negative 1/2, negative times a positive will make that a negative 2 over 2, which is 1, and then get y by itself by adding 4. So the equation of the line that is perpendicular to this given line and goes through this point would be y equals negative 1/2 x plus 3. I apologize that some of this was a little bit slow in the writing, as this was the first time I was using this new recording tool. I hope that didn't annoy you too much. Good luck. If you have questions, please let me know. And I hope this helps you out.